Okay, hello everybody. We're live again. This is the last time on air for our course, so thanks for joining us throughout all these. And again, they're all archived on YouTube. So we're very happy today to have with us Brook Osborne and Baker Franke from code.org, and they'll be sharing some things about code.org in general, as well as some of the things they have planned for CS principals in particular. So I just wanted to do a check. Is everyone hearing me okay?
I hear you great.
Okay, great. All right, so I had some audio problems last time, so let me know if there's any issue of that. So let me just go ahead and introduce Brook and Baker, and then let them take over and tell us a little bit about some activities at code.org. So Brook Osborne is the high school program manager at code.org, where she develops programs for high school students and teachers, including the curriculum and professional development. And previously she was director of outreach for the CS department at Duke University. She taught courses and worked with educators and administrators in both formal and informal computer science education. She also served as the pilot and outreach coordinator on the CS Principals Project, where she worked with project leadership and pilot teachers on the development of the CS Principals program. Those out there watching, if you remember from Unit 1, we also had Brook and Owen come in and give us some overview about some of the curriculum framework and performance tasks. Also with us is Baker Franke, who's a K-12 curriculum manager from code.org. He's a recent former high school computer science teacher at the University of Chicago Laboratory Schools, where he taught introductory computer science and advanced courses for 10 of his 13 years of teaching. Baker is a former vice president of the Chicago chapter of the CSTA and the state liaison for Illinois. And in 2011, Baker was awarded the NC Witt Educator Award for encouraging young women in computer science, and he was also named the Champion of Change by the White House. So in 2003, he was named the Golden Apple Teacher of Distinction by the Golden Apple Foundation, and he believes fervently that computer science should be a core subject in K-12. So Brook and Baker, can you go ahead and give us a little bit of introduction about some things you've been working on and anything you want to address with code.org in general, and then particulars about CS principals?
Yeah, great. So first we want to really thank all of you for having us. We're excited to talk to you, and for those of you participating in the MOOC who saw Unit 1, I'm happy to be here again. I want to give a quick overview of all the stuff we're going to talk about today, and then we can talk a little bit about code.org. Since in Unit 1 I told all of you, with Owen Astrachan, I told all of you about the performance tasks and the curriculum framework, I'm going to give you a little bit of an update on that because there have been some changes. So the curriculum framework itself has gone through a revision that's now available online, and the performance tasks have gone through an update as well. So I'm going to talk to you a little bit about that, and Baker is going to give you an update on the curriculum that code.org is developing for the CS Principals course.
Yeah, and just a brief word of introduction. How recently was I a high school teacher? 4 weeks ago. So I'm new in the job here. Also, I'm sick, so if I start coughing, pray for Brook.
I'll just slide over. Okay, so we wanted to talk a little bit, like I said, about these changes and updates to the performance tasks and to the curriculum framework. So everyone should see some slides right now. Can folks see those? Excellent. Okay, so that's a really quick slide. The first thing that I want to tell all of you with respect to the curriculum framework, in the video that Owen and I did that was an overview and a walkthrough of the CF, you saw these exclusion statements, and several people wrote in to Jeff and the rest of the folks running the MOOC to say that they couldn't actually access a version of the CF that has this information. And that's because it wasn't available online yet, but I'm happy to tell you that it is now available. So you can access that via the link that's on the screen right now. So bit.ly/CSP-CF-2014, or by going to the CS Principals website. And the biggest change you'll see in the curriculum framework now versus what was available before is the presence of these exclusion statements. And if you want a refresher on how those work, I would encourage you to go back to the CF walkthrough that Owen and I did in Unit 1. But just very quickly, it is the information or the topics that you specifically do not have to prepare your students to know for the assessment and exams. that's really the brunt of the change to the curriculum framework for this draft. The next thing I wanted to talk about was updates to the performance tasks. So previously we had 3 tasks. We had create, explore, and investigate. And now we only have 2 tasks. We have create and explore. So the task that has been removed or been done away with is this data task that we had before. And then in addition to getting rid of that task, that investigate task, there have been some changes and updates to create and explore. So I have a couple of bullets here for each that just highlight some of the biggest changes that you'll see between the two. These also are available online. They're available on, or will be available on, the CS Principals microsite that the College Board hosts. But you can also get them by going to apcsprincipals.org, which is a new site that is not fully functional but is under construction, and it will soon be redirected to csprincipals.org. So if you go to apcsprincipals.org, you can find the language for these tasks, but I'm going to just quickly give you an overview of high-level changes. So for the create task, which is the programming task, students will not be submitting source code. Instead, they're going to submit a PDF of their code. And then they'll also submit a 1-minute or less video of their running programs. And the reason that says programs is because there's one video for their individual program and then one for their collaborative program. They'll do 2 videos. And it will illustrate the intended purpose of the programs. And then they're doing a reflection and write-up on the collaborative portion, just like before, but this time they have a collaborative write-up, which means they're actually developing the write-up with their partner. And then there's also a piece that they do independently. For the explore task, which is the piece where they write about an innovation, they now have to specifically and explicitly describe the relationship between data and the innovation that they select. This is part of how the College Board is going to continue to assess understanding and knowledge of data, despite the fact they no longer have the data task. That's one of the goals of adding this piece into the Explore PT. They also have to add a visual artifact. There was, in the last version of this task, there was a sort of ambiguous artifact that had to be included, but now it's specified as being visual. And the 3 domains that are sort of described in the task, in the language, are a visualization, a graphic, or a movie, where the movie is 1 minute or less. And the goal of this artifact is to provide additional insight about the innovation that is being explored. And then the final thing that you'll notice that's a pretty big change is that there's a wider date range for references now. It used to be references from the academic year when the task is being completed, and now students will have a 2-year range that they can pull from. So again, this is in no way sort of the full scope or scale of the changes, and I would encourage you to check them out yourself if you're considering using the performance tasks in your classroom. But what that does give you is sort of a quick overview of what some of the biggest differences that you'll see.
I'm wondering now if there were any questions or anything that came in about the changes to the curriculum that we should address now.
Well, one comment that I've had, like last week at the CS Principal Summit, was there was some concern that the data unit might be going away with Investigate. So I don't understand that to be true at all, but have you heard anything? I mean, I think that's pretty much the case. The data unit stays intact. It's just the removal of the performance task.
Yeah, so something important about that is that, you know, students will still be expected to learn about data, and those learning objectives and the big idea have not disappeared. It's just the way that will be captured and assessed is going to be a little different. The College Board, when we were in Philadelphia for a meeting with them last week, they felt pretty strongly that they'll be able to capture that through other performance tasks and then also through the computer-based assessments that students will do at the end of the year as well. So don't take this to mean that data doesn't matter. It's just the way of measuring that is going to be a little different.
Yeah, and I think if you, at the CSTA conference, gosh, was it just earlier this week? It's been a long week. A lot of people were saying that the fact that the performance task is going away is actually, you can really use that as a benefit because all the data learning objectives are still there, but it gives you an opportunity as a teacher to intervene with the student and maybe walk them through the creation of something that is performance task like. Like you could actually use the old performance task language as sort of a dry run for a different kind of thing with students, and I think that you can scaffold it much better in a way that might prepare them for the real ones that they have to do later. So it's a good thing.
And I'll say, sort of as a specific thing that I've heard at least 10 teachers say in the last week and a half, folks are saying, you know, we're going to use as an assessment in our course or as a project in our individual courses, we're going to use the data PT exactly how it was, but the only thing we're going to change is that students can collect their own data, so they have some more agency over the data and some more interest in the data maybe. So still leveraging the thoughtfulness of that project, because ultimately it is a really cool project, but it's still using it in your course. And if you haven't already downloaded that, don't worry. The archived versions of old drafts of the performance tasks will stay available on csprinciples.org, so you'll be able to access that there. And I would really encourage you to check it out, both for what Baker referenced before and scaffolding your instruction for the other performance tasks, but also as a way to just teach and get students engaged with data.
So there were a few earlier questions that were not so much about CS Principles, but just code.org, questions about what you all have planned for the Hour of Code in terms of even helping teachers market that across schools. So can you say a few words about that?
Yeah, so Hour of Code is going to happen again this year.
Hour of Code 2.0.
It will be during CS Education Week again. And all of the resources we created last year will still be available, and we are working on creating some more. So there will be more ways to advertise to your students. There will be more activities that they can run through, similar to the Angry Birds and Plants vs. Zombies things that we created, but obviously we will again be partnering with outside groups to help provide other options for projects and tutorials that students and adults as well can work through. One thing I will say to resources for advertising, you know, videos are great, but it's also great to have stuff to send home, and it's also great to have stuff to plaster all over your school. So I've gotten some ideas from folks that I'm working on making happen. Some ideas for sort of customizing those posters that we have and that we send out, so you can present information about your programs that your school is going to offer, rather than just say, hey, it's CS Ed Week. You might have space to write in what kids at your school could partake in and participate in. So yes, we're still doing it. Expect it to be even bigger than last year. I don't even want to think about what our target for this year will be. It'll probably be 5 billion people or something. I don't know.
It'll be so good people without computers can do it. Yeah, I'm new here, but apparently the engineers are cooking up stuff for the Hour of Code that I'm not privy to, but apparently it's going to be awesome. The other thing is we're also looking to get some more, I would say, some CS Principles specific Hour of Code stuff in there from the curriculum that we're developing. So there'll be some sort of activity or something that students or teachers can do with students that will take roughly about an hour, but we're going to have a CS Principles tie-in to the Hour of Code as well.
So there's a specific question
Great.
by
So a couple other quick questions. Steve asked if the slideshow would be available. So
Yes.
okay.
We'll give it to Jeff.
Yeah, Jeff, you can do whatever you want with it.
Okay, thank you.
Slides. You really want those, I promise.
Okay.
Go ahead, Deepa.
Okay. Colleen had a very specific question. She wanted to know if the video that was made with Bill Gates, Mark Zuckerberg, Will.i.am, and Chris Bosch, would there be one similar to that this time around? Baker, Brook, thoughts?
I believe that we are making new videos for things. I'm pretty sure that even if I knew who the celebrities were, I shouldn't say. I don't know. But I know that new videos are being planned.
And you know, I don't know if we will have a video I don't know that we will be able to make a video that rivals, you know, the long video that we originally had talking about the importance of computer science, but our target for a lot of the materials we're producing right now are sort of short, both instructional and inspirational videos that would still serve to motivate and inspire kids around computer science, but we're always looking for new ways to do that rather than recreate something we've already done.
Okay. There is one more question which has been responded on Piazza, but I'm going to go ahead and ask it, and so that it's on record. What is the status of the curriculum discussed on code.org website for CSP? Here is a summary of what they claim. Code.org is currently creating a couple of curriculum consisting of daily lesson plans, videos, tutorials, and assessments. Check back often, as units will be released individually from now until fall 2014, when the entire curriculum will be publicly available. Download this timeline describing code.org CSP development cycle and release schedule. The resources will be distributed under a Creative Commons license. Owen's responses to this was that they have, excuse me, I'm sorry, they have pushed this back by a year and will be available by fall 2015. And before I continue, I'd like to give a minute to Baker or Brook to comment on it, and then I'll give you another response to this.
Well, first of all, I think our website needs to be updated to reflect that. Most of that is true. The plan for my little presentation here was to actually walk you through what we've created so far and what the timelines are on that and why we pushed it back. So I'm planning to address that much more deeply.
Okay, great. So then I'm just going to let this pass for now that Bucky had a further question too. I mean, we'll keep it on hold till we get to your slides. Thank you.
Sure. So should I go do that then?
Yeah, Baker, if you'd go ahead and talk a little bit more about your plans, that'd be great.
Okay, let me see if I can figure out how to use computers. Can you see that? Okay. So, oh, that's me. I've already been introduced. This is a shameless picture of my son, Ben, who I'm trying to get officially trademarked as the code baby. So you've now been softened up. The Code.org CS Principles curriculum. So this year we had a curriculum writing team of, I don't know if you know these people, Pat Phillips from Wisconsin was our editor, Rebecca Dovey from Code VA, Andy Kimmel from Madison West High School, and myself. We all came together to attempt to write a CS Principles curriculum, but we were all full-time teachers at the time as well, and that's the team. I'm going to explain a little bit about why Code.org is writing a CS Principles curriculum. I'm going to take you through sort of what we have created and what we are creating. Maybe give you time, depending, give you a little preview of something, and explain the timeline. So we're writing a curriculum because I think one of the things that the Code.org CS Principles curriculum recognizes is that it's being written specifically by high school teachers for other high school teachers, with the high school classroom in mind. And we just didn't see that that curriculum out there in the world. Most of the pilots that have been made, the most built-out products, were designed as university courses, as they should be, because it's an AP class, but then kind of worked back into a high school classroom. So we're designing a curriculum that is designed to be used at the high school level. We're writing it for, you know, one of the things that we're facing as a country is state by state, states are adding computer science as either counting for math and science credit or as even a graduation requirement in the state, and we're beginning to see people just clamoring for more and more resources to teach computer science and more new teachers to computer science. So one of the things we're designing our curriculum to address is how do we communicate an AP CS Principles course to someone who has never taught computer science before or may even be new to computer science in the first place? This is certainly true in districts that Code.org has actual partnerships with right now. So we're creating a head-to-tail curriculum. I do not expect you to be able to read the tiny little words, but Jeff is going to try. We have a plan for 6 units of study, and one of the things that we recognized when we were talking about it is that what really makes CS Principles different from, say, APCSA is its recognition that the internet exists and might have an impact on people's lives. APCSA is very, very straightforwardly a programming course. Our course will always be looking toward the internet and innovation and impact. And so the course starts, the theme of the course starts with considering how a single bit of information can be used, what it can represent, and more importantly, how you can get it from one place to another physically, which is really the foundation of how digital communication works. So students consider those ideas and even build their own little bit-sending machine. So that's where the course starts, and then we go through several units, and in the end, students will be, the programming artifacts that they produce will be web applications. And our goal is to have that be real, that the artifacts students create live on the web with a web address that they can send to their friends and family and show off those products, and that it will be real. So in terms of, one of the things we understand is that we really need to provide a rich set of curriculum resources for teachers, which means daily lesson guides. And so for every day of school, for the 140 to 150 of days worth of school that typically exist between Labor Day and the AP test, we have daily lesson plans for teachers that have pedagogical techniques built into them, activities, resources, extended learning, assessments, things like that. Our curriculum, I would say, is modeled on the ethos of the Exploring Computer Science curriculum, especially in terms of equity and inquiry. The whole Code.org's mission is to understand that computer science is something that every student in the country should learn. It is not a privileged discipline. And so it's extremely important that our course speak to all students. And so we've learned a lot through research and myself through practice of exploring computer science, how you do that, how you make the classroom an equitable place to make students really love computer science and want to do it more. We are also planning to create more, we're calling them widgets, but blended instructional tools, game-like things that allow students to really play with some deep ideas. So the thinking behind this is, I don't know if any of you have ever used CS Unplugged activities, but in my teaching career, every time I did a CS Unplugged activity, especially in a high school class, I felt like once we got the idea out, that was great, but then I wanted to plug it in and actually play with the ideas and have students really get deeper with it. And that's what we're planning to do as well. So I'll show an example of one of those later. But there will be a dashboard, an ecosystem of tools that student-facing tools that students can use, and teachers will be able to, assign those and see how their students are using them, etc. The programming, this is the question that comes up amongst existing computer science teachers. The programming language that we're going to use is JavaScript in the course. We're hoping, one of our plans is for this course to be the transition between block-based programming and text-based programming. The longer that we the longer that computer science has been successful and programming with block-based languages is successful, we think that students are going to arrive at high school having done like hours and hours and hours and hours of block-based programming, and they'll be ready to move on. And so we're hoping in this course we can make that transition. We have more videos planned as well. These ones specifically tied into the CS Principles curriculum. The idea of these videos is that it might not be Will.i.am explaining computer science concepts. We're trying to get some computer science celebrities in here to explain these concepts. So, for example, after students have spent some time creating an internet communication protocol using their bit sending devices, well, we're hoping that we can have a video of Vinton Cerf explaining how he solved the exact same problem. And so the idea is for videos to confirm or affirm students' belief, reinforce and extend rather than explain a concept. Another feature of our course is explicit preparation for the performance tasks. You know, one of the sneaky things about this curriculum is that you can't just like prepare to do well on the test. The performance tasks are significant things, and student success in the course is based on them. And so a lot of our activities and projects are scaffolded performance task-like activities, so that students should be well prepared when they get to the real thing. Brooke is going to explain a little bit about
the professional development. So we're going to build all this awesome curriculum, and that's going to be great, but then there are going to be folks who want some PD that helps to support that curriculum. So we are, and this is for our partner districts that we work with, we're going to be offering a PD model that spans across about 15 months, so starting in the late spring in the academic year before you start teaching the course. And in those 15 months, we're going to have a blended professional development that's a mix of online opportunities, sort of like what you're doing with Jeff in this MOOC right now, and in-person opportunities. One of the key features of working in a blended environment is that when the academic year comes around and you're teaching our course for the first time, it will give us a space to continue your support and your professional development while you're in the classroom. So we view this job embedded piece as being very important. We really want to not just give supports and say, here's a bunch of material, good luck, but we also want to provide a community and help the community of teachers who are using this curriculum and teaching this course know how to contact one another and know how to contact us to be able to get all the supports that they need. We're also going to have what we hope will be an integrated teaching guide support. So what that means is, in addition to having actual job embedded supports for PD, we also want to have a tool that helps you communicate with one another and document your thoughts and ideas on a lesson while you're just using and viewing the lesson rather than giving added steps there. All of this, much like our curriculum, this goes back to a question that Jeff posed before we started talking through this, all of this is going to be available for free online if you want it. So even though we will only be providing in-person PD to the folks that we're partnered with, all of our PD plans will be available. All of the online stuff that we have will be available. So it's not like if you're not in our partner districts, you can't use our stuff. All of our curriculum, all of our tools, all of our professional development will be available online. The caveat there for timing, because we say that and then people want to know when it will be available, is that we want to field test and respond to the cries of our users before we push it out to everyone else. So it might not be available as soon as you want it, but I do assure you that it will be available as soon as it's been developed and revised.
All of Code.org's educational programs, and we have kindergarten through high school programs, are evaluated by this group at the University of Chicago called Outlier. And CS Principles is not going to be, our CS Principles course won't be any different. That's not entirely important for this audience to know, other than we're not just going to put something out there throw it at the wall and then walk away. There's an iterative cycle to improving the course that will happen in preparation, in gearing up for the year of the actual when the assessments actually go live. So, and we have a few years for that. So this group at the University of Chicago is going to help evaluate both our curriculum and the professional development and the whole implementation of our program so that it can improve. I wanted to give you a little flavor of something that's in the class, and if you all were at the CSTA conference in Pheasant Run, I apologize for giving you the same example. If any of you have ever seen the text compression CS Unplugged activity, this is a, oh, don't go to it yet.
They're not going to be able to see it.
Oh.
So talk.
Oh, sorry, we're having technical difficulties. Okay, so in the course, one of the things students need to know about is how bits can represent information, and in the course we layer on layers of abstraction. So we understand how bits can be used to represent a number, and students think about how they can represent other kinds of information with bits, such as text and images. And when you start to think about information representation in binary and you add in the internet, you also need to consider like how efficient is that representation. And if I have to send a ton of bits from one place to another and I can't make my connection any faster, well then I need to have some way to represent the same information with fewer bits. And that brings in the idea of compression. And the CS Unplugged group has this fantastic unplugged activity for text compression, which we also have in the curriculum, but I want to show you an example of what plugging that in looks like. So let's make sure that you can actually see.
Can you see the tool?
We need to hear audio.
Yeah, we need to hear. Yes?
Jeff, can we hear? Okay.
Okay, thank you.
All right, so the way this tool works is you select a poem, and text compression works by finding patterns in the text that's there and replacing multiple strings of bytes that occur with a single byte that's encoded, which in something we call the dictionary. So as an example, I recognize that the word pitter appears many times in this poem. Pitter patter, listen to the rain, pitter patter on the window pane. And if I type pitter into the dictionary, I can see that it replaces it. The sun character, yes, is not an official ASCII character. It's a fill-in, but it can be. We can replace that whole word with a single byte or single character, and down below it shows how much it compresses. And if I type in patter, I can do that. And then a really interesting thing that you can do is I recognize that sun space umbrella space sun space umbrella space appears twice. So I can actually copy that and I can put that into the dictionary too. And I can have the dictionary sort of refer to itself, which is actually how LZW compression works. Let's see, is there anything else in there that I can do? I don't know, in the moment like this, I'm not sure I can do better than 35%. Maybe I can. But that's an example of the tool. And so the activity here for students is to pair up and with a partner, try to compress, pick a poem, and try to compress it as much as possible. And what's interesting about this problem, if you know text compression, is that it's actually an NP-hard problem. So there is no right answer. It's when I've done this with students, they really like the idea of the computational thinking. You can also see there's tie-ins here to recursion once we get to programming later. There was one more point I wanted to make that I can't remember. Oh yeah, the final question here is to ask students. This is approaching our unit on algorithms. The final question here is to ask students, can they write a set of instructions to tell somebody else how to compress a poem to make the best compression possible, which is actually a very hard challenge, but it begins to approach the idea of algorithms. So that's a little flavor of the kinds of things we do in our course early on. And I don't know if you guys have spent any time trying to develop your own CS Principles curriculum or what's out there, but when I was a piloter a few years ago and in thinking about CS Principles up to now, it's dawned on me that there are really 3 keys to student success in the CSP course. One is I really think that abstraction is a key that unlocks all computational thinking. That's why we spend a lot of time early on just thinking about a single bit and what it can mean, and building layers and layers on top of that. Because I think in doing that, it helps make sense of a lot of the world around you. So abstraction sort of never ends, and a student's ability to think abstractly in the layers the way that we do in computer science, I think is a key idea. Programming, right, this course isn't about programming, but programming is something that we need to do, and I think we might classify the programming that has to go on as, sort of heavy scripting. Students need to be able to program enough to create a programming artifact that is of their own design, and that means they need enough programming under their belts to be able to process simple data inputs, either from the web or from simple files, and produce output in some way, which means loops. So it's not programming isn't the object of study in this course like it is in AP-CSA. And I think sneakily, your ability to write English prose is going to correlate highly with your success on the performance task. And so we have a lot of writing built into the course as well. Students write almost every day. So that's the sort of big talk on what it is. And if I can figure out how to use computers again, we'll come back and we can take questions.
Great. This was a fabulous presentation, Baker Brook. Thank you so much.
Oh, I didn't.
We have quite a. Go on, please. Somehow
I lost the slide on timelines because people want to know when it'll happen. Sorry. So the schedule right now is that the writing team, we have a preliminary draft of the curriculum, and as Brooke said, we are, in the next several weeks, we are getting together a group of what we're calling field testers. We're going to test out some of our lessons over the course of this academic year, and we're going to do this in batches of lessons. And so we don't want to release to the public or publish on the website lessons that haven't been tried in the classroom. The other constraint on us publishing lessons is that our digital tools, like the widgets and whatever programming tools we have to go through our engineering team at code.org. And they are busy working on K-5 curriculum, and realistically, they're working on Hour of Code 2.0 for some time. And so we're still figuring out a schedule for when we can have those tools. We don't want to release a lesson that's reliant on some really awesome tool without having it. So that's part of the reason for pushing the schedule back as well. We will probably, once a lesson is ready and the tool has been, if it has a tool, it's been made and it's been field tested and we've incorporated the feedback from that field test, we will publish it on the code.org website. And we're looking for a way to have people be able to subscribe so that they'll be notified if and when new things are added. We just want to be responsible about how we release things so that people don't think that people don't get the wrong idea about the lessons and being able to use them. So our big goal is that the curriculum will be done and published by May of this upcoming, the 14-15 school year, ready to do professional development with it in our partner districts over the summer. So that gives us, we would then call the 15-16 school year our pilot phase, which is with our partner districts and anybody who wants to grab the curriculum and try it out and give us feedback. That'll be the 15-16 school year, and that's when a lot of evaluation is going to happen with the outlier group from UChicago, so that we can make refinements and revisions so that it is definitely ready for the real thing. So that's the timeline. I'm sorry I had to speak it. It's a lot easier to see on a slide. I accidentally deleted it before before publishing it. So
quite all right, Baker. I think it was fairly clear. Is my voice loud enough? Are you guys able to hear me well?
Yeah.
Great. First, thank you so much. There was a lot of feedback from the audience on how thankful code.org, how thankful they are to code.org. I must tell you that we have a lot of viewers. At this time, there are 24, and we are being flooded with questions. So bear with me as I've queued them, and I just find the order in which we have to get. At one point, Steve wanted Baker to know that thank you for the information on the performance tasks, and also that he believed that the writing part would be a much bigger emphasis, and that the performance tasks, as you both have described, he thinks that the writing is very important, and it's good that there is so much emphasis to it. There's a question by David Thompson. He's at the state of Hawaii, and he's scheduled to teach AP Computer Science this upcoming year. And his comments are as follows. Last year, I followed through what the code.org plan. I taught the Hour of Code to Boy Scouts, Chamber of Commerce, and talking to a lot of local legislatures about making computer science a math credit. I have learned a lot about it. Is there someone I could talk to help me provide information to my state legislatures? I have looked into what Alabama is doing. So he's from the state of Hawaii, and he would like to know what he can do to get computer science a math credit.
So the first thing that I would recommend doing is going to code.org/promote, where there are a bunch of resources that you can use in those discussions with your local legislator, and also gives you sort of, like infographics and things like that, but there's also a place for you to sign a petition and things like that.
The other thing about that promote page is there's a pull-down menu. You can choose your state, and it'll show you whatever data we have about your state and computer science counting or not right now, and also provide you with state-specific. I think that there's a state-specific flyer or handout cheat sheet about data for your state.
And I'm trying to look this up right now as we're talking, so sorry that my face went off to the side. But the reason I was looking for this is, we have groups, or a group at code.org that's working on advocacy to try and work to get computer science to count. And if I'm going to say this, and I apologize to people at code.org if this is the wrong email address, but I think if you send email to help@code.org, that will get triaged to the right people who will be able to help connect with you and give you some maybe better advice on what you can do to help make stuff happen in your state. But on hanging off of the code.org site, there are a couple of opportunities to do what Baker was saying, and do stuff specific to your state, but also just get resources that are really helpful when you're having those discussions with local leaders.
Great. Bruce Schwartz says that many of my teachers, such as in PE and art, love the idea of using offline activities during the hour of code and would like to see more. And in the same vein, Matthew Keating adds, Brook and Baker, enjoyed meeting you all this week at the conference. Thank you for all your work. Has there been any talk of cross-curricular projects with other subject areas? Perhaps the need for more introductory CS courses would be clearer if some upper-level cross-curricular projects were available. So they're looking for some high school cross-curricular work, I guess, in terms of curriculum. I guess, Baker, you were talking about the timeline. I think they would like to see if there's any cross-curricular work that's being planned?
Well, so a couple of things. I'll sort of take those separately because I think in some ways they are separate. So for things like Hour of Code and this idea of unplugged things or computer-free things, last year we put out 2 unplugged lessons in partnership with the Thinkersmith group, and we're going to continue to put out unplugged lessons. And in fact, the K-5 curriculum that's being developed right now, and actually I think launches today, has a really rich set of unplugged activities. And other folks, we did not invent the unplugged activity. There are lots of those. So I think that's, for me, one of the big areas of focus for things to think about pushing out for Hour of Code this year is more of those unplugged or computer-free activities. So that point is well taken, and I appreciate hearing it. As for the point about cross-curricular things, something that is, I think, really powerful about curricula like the CS Principles program is that it requires thinking about computer science in context of the broader culture and broader society. So that really gives students a space to think about how computer science might impact those other things they're interested in. And it also is kind of a mandate for teachers to teach computer science in the context of those interdisciplinary or multidisciplinary spaces.
Great. Gail Reed had a question. Before that, hey, Owen, welcome into the group. Glad to have you here. Yeah, Gail Reed wants to know, or rather states, that I'm a 6th, 7th, and 8th grade middle school teacher. When you label resources K-12, are they specifically for high school or middle school or both?
We have specific. Right now we have K-5 programs. We are endorsing some middle school programs, and we have high school programs as well. So K-12 actually literally means from kindergarten up through 12th grade. It does not imply high school. However, in computer science education parlance, I think that it is true that K-12 often gets mixed up with meaning high school, but we don't mean it that way. And if you look at the code.org website, you'll see those programs, and in fact, there are a lot of changes that are, I'm not sure if they've actually been released yet. They are going to be in the next week or two. Our whole K-5 program, which actually has 3 bands of courses for early readers, kindergarten through 1st grade, 2nd and 3rd grade, and 4th and 5th. Courses for those classrooms. So we run the whole gamut.
Yeah, I would, as far as things that might be a little more flexible, if you look at what's currently posted as the K through 8 curriculum, which is a mix of online and unplugged activities, that's pretty appropriate, I would say, for a 6th through 8th grade range if they don't have any computer science background. So that's what we released following the Hour of Code last year. And if this teacher is looking for specific activities, I think that would be a great place to look.
Fantastic. We do have some PD questions, but I'd like to repeat Bucky's question on the curriculum that he had asked earlier. Code.org has released Lesson 5, Sending Bits, and Lesson 6, Encoding Images. Do others exist that can be pre-released that we could see, is the question.
So this is a really tough question, and so for example, those 2 lessons are probably going to be renumbered in the curriculum now. They are not fixed. It was we released those to give people a sense of what we were up to. With the course at the moment, we have drafted something close to 120 lessons. But they are in the nascent stages. And in working with a curriculum writing team at the University of Chicago, the team that publishes the Everyday Math Curriculum, which is the largest, most widely used math curriculum in the United States, we have concerns about scaling and using the curriculum properly. And so in conversations with them is part of the reason we decided to change the release schedule here. So all I can say is that we will be releasing things as we go, but not until they have been through at least an internal revision process and field tested first.
And I'll build on that and say that it is extraordinarily likely that we will really only release in order. So we don't want to give you Unit 5 right now, even if we think Unit 5 is in great shape, because Unit 5 depends on using 1 through 4. So that's part of this, is that we want to be responsible with how you as educators might use the material we give you, and we don't want to give you stuff that you can't really use because you don't have the stuff that's supposed to come before.
And again, our audience is actually probably, it's unlikely that it's the group viewing this CS Principles MOOC. Our audience are the teachers who we don't know exist yet. And so when we publish things publicly, we want it to really be usable. So.
Great responses, thank you. I have to say, before I move on to the PD component, that there are several people here on Piazza saying that this has been a fantastic hangout, and it's been very engaging. Okay.
I aim to please, Tifa. I aim to please.
Hey, it doesn't take much effort from your part. Seems to be a flick of your finger. Bruce Schwartz says that I believe Code.org's program is largely available to public schools. However, I work at an independent school that is very interested in becoming a partner school. We would love to have an access to in-person PD.
Yeah, so at this point, our partnership model really does tie specifically to school districts. And what that means is, public school districts. That does not mean that in the future there won't be space for independent schools. And going beyond that, I would say, one of the reasons that we want to make all of our resources and material available online is because we want to give other people the ability to help run these things. So I'll give a specific example of how I imagine something like this might work out in a city or in a region. So once we have been with a school district for a few years and have helped to produce facilitators to deliver professional development in that region, I think this is a big part of our sustainability model. We would hope that people within that region, not just in the school district, can use the expertise that's being cultivated in the teachers that we're working with to help produce more PD for people down the line. Yeah. So I don't want to say that's the only way that you can ever get PD from us or with us, because I don't think that's true. But under our current model, our emphasis really is on public schools, though we would totally encourage you to use our material. And I think that, maybe it would be possible for a bunch of independent schools to get together and sort of have PD that they help to bring in. Or if, as an independent school, you have a strong connection with your public school district that's nearby, that might be a way to get an agreement.
As a lifetime independent school teacher, I'm very sensitive to this issue. And we have had talks internally about how to address it, because it's not just independent schools. There are other, even public schools that sort of aren't tied to a district, like charter schools and other kinds of schools. And so our initial model was partnering with school districts, but we are trying to figure out a way to work this out. I think that another easy model is if you have a CSTA chapter locally, right? CSTA is anybody who's teaching computer science. We might partner with a CSTA chapter to provide professional development as well. That can be the organizing body. That's not official yet, but that's an idea that we've had. But we're very aware of that issue.
Cool. Pam asks, are there any plans to provide PD for non-CS teachers? There's been a lot of training around and a lot of NSF-funded grants and other kinds of training that's around. However, as a teacher with no CS background, the online course can get quite challenging. Some of these videos seem to move at a pace that requires some background knowledge. Does Code.org, when you offer PD, will it be geared towards novice teachers, or are you going to assume that there is some amount of CS background?
So the short answer is we assume nothing. And that's another feature of our curriculum, is that it is for both students and teachers who are new to computer science. So CS Principles was designed as sort of it is an entry-level course, but it has college-level rigor. but it's really the coupling. I wouldn't recommend if you don't have any CS background trying to teach it without doing the in-person professional development. But again, it's the scaling, right? That if we are going to achieve the goal of every student in America having computer science, the people teaching computer science 5 years from now, that 90% of them they don't exist yet. And so part of our scaling and outreach model is specifically about making sure that we can enable or convert teachers from other disciplines to computer science and make them successful teaching CS principles. And a lot of that has to do with the way that the curriculum is designed and its instructional activities. So, for example, we don't have something that says lecture about minimum spanning trees now. We don't have that. We have inquiry-based activities that let the students explore these ideas and learn them, and the teacher can do it without having a CS background.
And I would also say, from a professional development perspective, if every teacher is different and every teacher's level of comfort with being in a classroom and teaching material that they don't feel particularly expert with, everyone's comfort level with that is different. So I don't think any of this is to say that, hey, you should feel comfortable doing our stuff, and if you don't, then you're doing it wrong. And frankly, that's because CS Principles, as it stands right now, is slated to be an AP level course. And if you don't know any computer science, it might be a good idea to start with a non-AP level course. Start teaching a non-AP level course. I think that might help sort of ease your way into being comfortable in a CS classroom. And at code.org, we're helping to scale the Exploring Computer Science program, which is a program out of UCLA in partnership with the LA Unified School District that's been around since 2009, I believe, was the first year the curriculum was part of why we're working with them is because it represents a really excellent introductory high school course that is appropriate for high schoolers with no experience, and teaching it is maybe a little more attainable and comfortable for folks who, as teachers, don't have a lot of CS expertise or background. But this is part of why our professional development model lasts for 15 months, is we want you to be supported on the front end during teaching, and then give you space to reflect and move on after your first year in the classroom with what might be a new content area, but at the very least is a new curriculum.
Bruce Schwartz asks, maybe have something like a code.org certified trainer program, similar to the Google Education Trainer program. Would that make sense?
So I'm got a couple of answers. The first is that our professional developments are all tied, and this is true for kindergarten all the way through our high school programs. Each PD is tied to a specific course, and each PD is tailored to focus on both the teaching practices and the classroom dynamics and environment that we would hope that you can achieve in that course. So we have, as part of our sustainability model, a pathway for teachers to become facilitators for both their local teachers in their local schools and districts, but also if they want to come and work for us as facilitators, it turns out we need that. So this is sort of a way to work on that from both sides.
There are also other professional development opportunities out there for CS Principles that aren't code.org.
Right.
And maybe, I don't know if Owen wants to say something about that.
In a minute, if I can just make a comment here about, there's one from Lisa, and then Owen, would you like to talk about some upcoming PD opportunities? Would that be okay?
Sure.
Great. So Lisa asks, she's from Ohio, Lakewood, Ohio, right outside of Cleveland. I didn't notice any Ohio schools in the partnership list. 2 questions. Are there any partnership schools in Ohio? We received an email from code.org stating partnerships were full and they would be in touch with us in future. Do we need to do any additional follow-up, or will code.org be in touch with us to let us know the status of our partnership? Thank you for all the resources and support. It is very greatly appreciated.
Well, Lisa, I am from Ohio. I grew up in Cincinnati, so I would love to get into Ohio. And to your first question, are there current partnerships in the state of Ohio? No. To your second question, is there anything you should do? I would say it never hurts to apply again. What are you going to do, like show up too many times in our database? That's not a bad thing. One thing that's really powerful in favor of schools in Ohio right now is that Ohio just flipped to count computer science towards graduation. So that's a really good lever for you to use in getting there. It is true that for this year, we filled up rather quickly, and we went mostly to places where we either had efforts already in progress, like here in Chicago, where ECS had a strong presence, or where there was a pathway for us to work with a lot of teachers. And I would really encourage you, Lisa, you and your administrators that you work with to apply again, not because you will have fallen off the radar, but that will move you up the list.
Great. Owen, the floor is yours.
I was just going to mention that in addition to the fantastic PD that code.org is going to be offering next summer, that there are many other PD efforts that will be underway in 2015 that will, some of them will be facilitated through the College Board, and some of them will be facilitated through other projects, some NSF and some others, and many of them will be open to everybody. So it won't be that you need to be part of a school district or a school that's partnering with someone. Some of them will be, but I know some will be coming online soon in terms of information being available that will be open to all teachers. And at least a few of those will be teachers will receive a stipend for attending them, and they can be from all backgrounds. In terms of Ohio, there is an NSF project in Ohio trying to get the Compass project from University of California, San Diego into Ohio schools, and you can find information about those things on cs10kcommunity.org. So keep your eyes and ears open, and many of these projects I'm sure will be talking with the folks at code.org to make sure that we're leveraging the best practices that they're using.
Great. That was extremely useful information, Owen. Thanks. Baker, Brooke, last words of wisdom. The floor is yours.
Cough, yes.
No words of wisdom,
no
but
words
a lot
of
of
wisdom.
coughs.
No, thank you, everybody who's listening in. I'm at least very excited about the potential of what we're creating at code.org because I'm a high school teacher, and I really want to create things that I know high school teachers really need, and that's our goal, is to address the needs of those teachers out there, both the existing and the new ones that we don't know exist yet. And so thank you for participating and continue to do good work. Remember, computer science is for everyone.
And I'll add to that by saying, you know, if questions come up over the rest of your time on the MOOC or even after the MOOC is over, you can feel free to get in touch with us. We're both enrolled in this course. So if you post on the Piazza, Jeff can point it to us, and if it's something we should answer, we'd be happy to do that. Or if you want to get in touch with us directly, it's just our names at code.org. So Brooke at code.org and Baker at code.org. We'd be happy to hear from you. So thanks, everybody.
All right. Well, thanks, Brooke and Baker, for helping us with that, and a lot of requests for the slides, so we'll make sure we pass that on, and a few more questions are coming in. We'll get to you all as well. So this is kind of sad because this is our last hangout on air for the MOOC. Maybe since we're so far behind on the schedule, some other thoughts will come up, and we'll see if we can join the class back together, but this may be it. So we're about 2 weeks behind now, so the schedule is moving on, and we are talking among ourselves about how to pick that up, and the Snappy Bird example has been out, so make sure you're trying the Snappy Bird, and the 3.5 will be out, and we actually have all the videos already recorded except for 2, so those will be coming around quickly, and we'll update you on the Piazza site for that. So thanks again, and this will be archived for those who couldn't make it. We'll post that on Piazza as well. It'll be on YouTube, on our YouTube channel. So thanks again, and you all have a good weekend.
Thanks, everybody.
Thanks.